In 2016, a computer program did what many scientists thought was decades away. AlphaGo defeated the world champion at Go, a game where the number of possible positions exceeds the number of atoms in the observable universe. The architect of this system is Demis Hassabis. To understand how he built an intelligence capable of outperforming human intuition, we have to go back to a childhood spent mastering rigid mathematical systems. Born in London, Hassabis was a chess prodigy by age 4. He viewed the board as a network of fixed rules and absolute consequences, learning to think several steps ahead within a closed environment. By 13, he reached master standard and captained English junior teams. He spent his early adolescence navigating high-level strategies, where every move followed a strict logical progression. But Hassabis saw the limits of the chessboard. He bought a ZX Spectrum computer with his tournament winnings and taught himself to program, looking for a way to apply that same systematic logic to something larger than a 64-square grid. Teaching himself to code provided a new perspective. He moved from playing within a game's established rules to building the frameworks that defined how a system functioned. At 17, he joined Bullfrog Productions to co-design Theme Park. The game was a massive success, requiring him to program a digital world where thousands of variables, from ticket prices to visitor happiness, interacted in real time. He later founded Elixir Studios, specializing in simulation games that used artificial intelligence to manage the behaviors of entire fictional populations. During this time, he recognized a bottleneck in software development. Traditional game AI was static. It could only perform tasks its creator had explicitly programmed into the code. Hassabis realized that to create a truly adaptive machine, he needed to pivot away from game design and study the biological mechanisms of human intelligence. He returned to academia, pursuing a PhD in cognitive neuroscience at University College London to study how the brain processes information. His research focused on patients with hippocampal damage, looking for the specific connection between the ability to remember and the ability to imagine. He discovered the hippocampus uses identical neural pathways to recall the past and to imagine future scenarios. This suggested the mind acts as a biological simulation engine. We use memories as raw data to construct and test different future paths before we take action. This finding became a blueprint for his work in AI. A machine that could simulate and plan for the unknown would be far more powerful than one that simply reacted to preset commands. In 2010, Hassabis co-founded DeepMind. The company's mission was to build general-purpose learning algorithms that could master complex tasks without being told the rules. They tested these algorithms by feeding them classic arcade games. The system only saw the raw pixels and the score. Through millions of internal simulations, it learned to play at a level that surpassed human experts. This approach led back to AlphaGo. By simulating millions of matches against itself, the software developed strategies human players hadn't discovered in thousands of years. DeepMind used these digital games as a high-speed laboratory to prepare the algorithm for the more chaotic variables of the physical world. DeepMind applied this learning model to the 50-year-old protein folding problem, a challenge so difficult it has been described as a grand mystery of biology. Proteins are the building blocks of life. They begin as a linear string of amino acids, but their function is determined by their three-dimensional shape. With trillions of potential configurations, predicting a protein's fold based solely on its sequence was a massive computational barrier. Hassabis treated protein structure prediction as a 3D geometric puzzle, tasking the system with finding order within a vast space of possible outcomes. In 2020, their AlphaFold system reached atomic accuracy, providing a solution to a problem that had frustrated scientists for half a century. This breakthrough allows researchers to see how proteins interact with diseases, which can significantly reduce the time needed to develop new medicines and treatments. Since its release, AlphaFold has been used to map the structures of all 200 million proteins known to science. This achievement earned Hassabis the 2024 Nobel Prize in Chemistry, recognizing the impact of using AI to solve a fundamental scientific bottleneck. The child who learned the rigid rules of chess built a system that navigated the infinitely more complex rules of protein folding. He demonstrated that by modeling the underlying logic of a system, artificial intelligence can solve scientific problems that once seemed out of reach.